Okay, so here's a sketch of the exponential graph y equals 2 to the power of x. Let's just put in a bit of information. When x is equal to 0, 2 to the power 0 is equal to 1. Anything to the power 0 is actually equal to 1. And when x is equal to 1, 2 to the power 1 is going to equal 2. Similarly, when x is equal to 2, 2 to the power 2 is going to be equal to 4. So this is what the exponential graph looks like. Now, say we had a value here between 1 and 2, say 1.5 for example. What power of 2 gives us 1.5? To do this, we need to introduce the inverse to the exponential function, which is called the log function. What we can do is take logarithms to base 2 of both sides in order to get our value of x. Now, to take logarithms, you're going to need to use a button on your calculator that looks like this. And the way that we read this is it's a logarithm. We want the base of the logarithm to be the same as the base of our exponent. And this is what we're taking the logarithm of. In this case, it is 2 to the power of x. We're not going to be able to put this in our calculator. So what we're going to need to put in is this log to the base 2 of 1.5. So if you put that into your calculator, you should end up with a value of 0.58496 and so on. Now on this hand side, on the left hand side of the equation, we've got log to the base 2 of 2 to the power x. And what this log to the base 2 actually does to this equation is it gives us x on the left hand side. So to undo 2 to the power x, we've done the inverse function log to the base 2. And we end up with x equals 0.58496. So, I mean, this is about right. We know that 2 to the power 1 is 2, so we're expecting this value of x to be less than 1. So I wanted to find the solution to the equation 2x to the power 11. Now, we know 2 to the power 3 is 8, and 2 to the power 4 is equal to 16. So we know it's going to be between 3 and 4. Again, we're going to take logs to the same base as the exponent, 2, of both sides. And log to the base 2 on this side is going to cancel out this 2 to the power x and just give us x on the left hand side. And on the right hand side, we have got log to the base 2, 11. If you put that into your calculator, we get 3.459 and so on. Now, we get slightly more complicated equations. 5x to the power 1, 5 to the power x plus 1, sorry, is equal to 27. Now, we know 5 squared is equal to 25, so we're expecting x plus 1 to be slightly greater than 2. Again, we're going to take logs of both sides, but on this side we're going to use a base of 5 now, because our exponent is 5 to the power x plus 1. And we're going to do the same on the right hand side, log to the base 5 of 27. Now on this left-hand side, what this log to the base 5 of 5x plus 1 is going to give us is x plus 1. And if we put log to the base 5 of 27 in our calculator, so we get x plus 1 equals 2.0478, and if we take 1 away from both sides, we get x equals 1.05 to 3 significant figures.